Hello, everyone. So as we finish up the final section of Chapter 12, it's going to be necessary for us to understand one more unit of concentration than the units of concentration that we learned at the beginning of the chapter. And that final unit of concentration is referred to as molality. Now, I know it sounds a lot like the term molarity, and we have learned about molarity as a concentration unit earlier in the chapter, but this particular unit is a little bit different than molarity. If you remember, molarity is calculated by taking the moles of solute and dividing by the liters of solution. However, molality is a little bit different. Molality is actually moles of solute divided by kilograms of solvent. And so this is the big difference. Basically, what you're going to have to do is be provided with a description of how much of a solute was added into a solution, but then you must also have some way of figuring out how much mass of solvent, and usually in our case it's going to be water, how much mass of water that solute was introduced into. Now, usually those types of descriptions are pretty straightforward. You're not going to find, any particular tricky language in terms of trying to figure out, how many kilograms of solvent there are. And so really the best way to illustrate this is to actually take an example and work through it. So here we have a problem in which case we have 25.3 grams of potassium nitrate, and they are dissolved in 125 milliliters of water. Now, in this instance, it is a little bit more challenging because if you notice, they're asking for the molality of solution. So I have to be able to actually turn these milliliters of water into kilograms so that I can do the proper calculation of molality. Now, notice, though, they give you some additional information. They're kind enough to give you the molar mass of the potassium nitrate, but also the density of water. And that's where we're going to be able to make that conversion between milliliters of water to mass of water. So let's actually go ahead and start putting in our information. As I said, molality, and molality is actually abbreviated with a lowercase m, which is in contrast to molarity, which is abbreviated with an uppercase m. But for molality, it's a lowercase m, and that is moles of solute per kilogram solvent. And so I'm going to go ahead and start to situate things in a ratio that looks like this with the given information. So we know we have 25.3 grams of potassium nitrate. And I know I have to divide that by the quantity of solvent. And so basically that quantity of solvent was 125 milliliters. Okay, now what I'm going to have to do is, and I'm going to take this in parts, I'm going to start with the amount of solute and I'm going to convert it to moles of solute, since I need moles of solute in my numerator to get the molal concentration. And so I'm going to divide by the molar mass of potassium nitrate to convert to moles of potassium nitrate. So now I've got my moles of solute in place. Now I have to worry about converting the volume of water to kilograms of water instead. And that's where the density comes in. But if you notice, the density is expressed in grams per milliliter. So let's go ahead and use that conversion factor as it's given. Since I have milliliters in my denominator here, as I work towards converting that volume of water to mass, and that means I need milliliters of water in my numerator in this conversion factor so that my milliliters will cancel accordingly. And I know that there's 1 milliliter for every 1 gram of water. Now, I'm not quite there yet because, again, I need to be in units of kilograms, so I have to do one more conversion to go from grams of water to kilograms of water. And if you recall back to the beginning of the year, our metric prefixes tell us that if I have this prefix kilo, then there should be 1,000 grams in 1 kilogram. And so these units will cancel, and I'll be left in units of moles of solute per kilogram of solvent, as I am expecting to be if I do this molality concentration correctly. If I go ahead and do that math and take 25.3, divide by 125, divided by 101.1, and then multiply by 1,000, I get a concentration of 2.00, and again we say molal. So again, this is molality, and we call that concentration molal, as in molal concentration, comparable to how we would actually call a solution that has a certain molarity, a solution of certain molar concentration. Okay, so go ahead and answer the follow-up questions attached to this pre-lecture tutorial video. Again, we'll be doing some additional practice on this tomorrow. Make sure you read the first couple of subsections of the final section of chapter 12. There's some additional terms in there related to solutions, colloids, and suspensions that we'll also discuss, as well as do more of these molality concentration calculations. Okay, so have a good night, and I'll see you in class tomorrow.